Have you ever pondered how a rocket, a massive structure of metal, defies gravity and soars into the vast expanse of space? It's a question that has intrigued and fascinated us for decades. These rockets, they are not just towering structures of steel and fuel, they are marvels of human engineering. They represent our innate curiosity, our unyielding desire to explore and understand the cosmos. The answer to this awe-inspiring feat lies in the fundamental laws of physics. For a rocket to break free from Earth's gravitational pull, it relies on a principle you may recall from physics, Newton's third law of motion. It's a fundamental rule that governs how objects interact, and it simply states, for every action, there is an equal and opposite reaction. But what does this really mean in practice? Well, imagine you're standing on a skateboard holding a basketball. If you throw the basketball away from you, you'll notice that you and your skateboard move in the opposite direction. The action of throwing the basketball results in the reaction of you moving backward. The force you exerted on the basketball is met with an equal force pushing you the other way. Now let's tie this back to rockets. A rocket moving forward is a bit like you on a skateboard throwing a basketball, but instead of a basketball, a rocket uses gas. When a rocket fires its engines, it's expelling gas at high speed in one direction, down. This action of gas expulsion is met with an equal and opposite reaction, the rocket moving up. The more gas that a rocket can expel, and the faster it can do it, the greater the thrust, or upward force, it can generate. This is why rockets have such powerful engines and carry so much fuel. They need to generate enough thrust to overcome the force of gravity pulling them down, and to reach the incredible speeds required for space travel. But remember, it's not just about quantity, it's also about efficiency. The efficiency of a rocket engine, its ability to convert fuel into thrust, is a crucial factor in determining how far and how fast the rocket can travel. So when a rocket fires its engines, it's essentially throwing mass downward and getting a push upward. That's the science behind the soar, a beautiful dance of action and reaction, of pushing and soaring, all governed by Newton's third law of motion. Now you might be wondering, what parts make up these colossal structures, and how do they work together to make a rocket function? Well, let's break it down. Firstly, we have the payload. This could be a satellite, a spacecraft, or even astronauts. The payload is the reason we're sending the rocket into space in the first place. It's the cargo that needs to reach its destination, be it the moon, Mars, or beyond. Then comes the propulsion system. This is the engine of the rocket, providing the force necessary to overcome gravity and reach space. It's the thrust that sends our payload on its journey. Finally, we have the structure. This is the body of the rocket, holding everything together. It's designed to withstand the enormous stresses of launch and space travel, and it houses both the payload and the propulsion system. Each component of a rocket has a specific role, and their harmonious functioning is what makes space exploration possible. So now we've unraveled the mystery of how rockets defy gravity and venture into the cosmos. We've taken a journey through the fascinating world of rocket science, from understanding the basic principles of physics that govern their flight to the intricate components that make up these incredible machines. Remember, it's all about Newton's third law. Every action has an equal and opposite reaction. This principle is the lifeblood of rocket propulsion. The force of the gases rushing downwards from the rocket is what propels it upwards, cutting through the Earth's atmosphere and into the vast expanse of space. And let's not forget the three main components of a rocket: the payload, the propulsion system, and the guidance system. The payload, the reason for the rocket's journey, whether it's a satellite, a rover, or even astronauts. The propulsion system, the heart and muscles of the rocket, powering it upwards against the pull of gravity. And finally, the guidance system, the brain of the rocket, ensuring it follows the correct path and reaches its destination. From the smallest model rocket to the gigantic space shuttles, these principles and components remain the same. It's a testament to the power of human curiosity and innovation. From launching satellites to exploring distant planets, these marvels of human ingenuity continue to push the boundaries of our understanding and fulfill our age-old fascination with the stars.